All right, so the second half of our unit is really just taking one step up from this. We've talked about factoring polynomials that are just basic binomials or trinomials, or that just have a GCF in common. Today, we're going to take a look at the second half of the day. We're going to take a look at problems that look a little different. We'll look at one of the special cases. Okay, in this case, it's a special case of a difference of a square. We talked about these earlier today. We talked, or not earlier today, or earlier this week, to see which ones we had. Okay, so if we take a look at this, so a special case, this special case is really when we have something like x squared plus 4 as my entire binomial. But we walk through this and it looks something. So our goal is that we're going to be able to factor this binomial that's the difference of a square. So if we were to do one of these problems, okay, say like number 2. If I was to distribute it using this FOIL, it would be 5x and 5x times 1. So it'd be 25x squared plus 5x minus 5x minus 1. When I simplify it, it would end up as 25x squared minus 1. There's my final answer if I were to simplify it. Now, the problem is that this is what I get to start with. I have to know that, hey, that's a difference of a square. If that's a difference of a square, I've got to factor it differently. Okay? So to do that, what I'm really going to do is use this following rule. Now, this is crazy confusing. Okay? It looks crazy confusing because you have the square root of a plus the square root of b, the square root of a minus the square root of b this time. That really just breaks down, say you have a problem that looks like x squared plus 25. Sorry, minus 25. Change that real fast. Minus 25. So now if I've got this, x squared minus 25, I look and go, okay, what it's really saying is, what's the square root of a? So what's the square root of x squared? What two numbers can I multiply together to get x squared?
X and x.
Just x and x. So they really factor out to x and x. And then someone saved me the other one. Same here. To get 25, ignore the negative for now. But to get 25, it'd have to be 5 and 5. So I'm taking the square root of both numbers. And then I rewrite it as x plus 5 times x minus 5. Now, I'm not going to get mad if you switch the terms a little bit and put minus first and plus second. It's not a big deal. But you will have a teacher sometime in your career that probably will mark that wrong if you switch them up. So the sooner you're getting used to just putting positive 5 and then negative 5, the better off you'll be. Okay? So when you break this ID down, this, in this way it's written, makes it looks really confusing. But here, once you break it down in number terms, it's not too bad. So let's jump in and try a couple like that. So let's take a squared minus 4. So if we take a, the two a's, the two numbers that make up a is a and a. The numbers that if you take the square root of 4, it's 2 and 2. So I'd end up with a plus 2 times a minus 2. That's the final answer. That's the factored version of a squared minus 4. Because I took the square root of a squared and the square root of 4 and wrote them in this term. And if I wanted to test my math, I'd simply come back out here and FOIL. A squared minus 2a plus 2a minus 4. And when I simplify, I'm left with a squared minus 4, and that's exactly what I had to start with. So I know I'm right. All right, let's take a look at this next one. What about number 3? So what's the numbers that make up 81? If I take the square root of 81, what do I get?
9 and 9.
9, exactly. What about x?
X and x.
X and x, yeah. Those I love. I love it when they're written just like x squared, because then I know it's just the two x pieces. Now, I'm going to ask you, which way should I write it? Option 1 or option 2? Which one of these, when I FOIL it back out, will be right?
The first one.
Option, well, let's test it. X squared, oh no, automatically is wrong. It's a positive x squared. That's a negative x. So my recommendation, I know it looks funny and I know it looks weird, But because of the way this is written, this is the correct answer. The 9 is first. And to get the negative x squared, you have to have a negative multiplying with a positive right here. So make sure, you know, if it's written in this direction, keep them in the same process, keep them in the same location to get the same answer back. Okay. All right. The last one we're going to touch on this page is number 6. The square root of 1 is just 1. I love that one. Now this time I've got both a variable and a number and a coefficient on my second term. So we just do them separately. What's the square root of 49?
7.
Yeah, so I've got 7. And the square root of y is just y. So I'm left with 1 plus 7y and 1 minus 7y is my answer. Those are my factored out versions. Okay. All right, now that we've kind of gotten a little practice on that, let's try a couple. I'll do number 9 with you, and then I'm going to ask you guys to do 10, 12, and 14. So if I take a look at number 9, the square root of 16 is what?
4.
Yeah. Don't get mixed up and say 2 and 8. A lot of kids will take it and divide it by 2. Keep that in mind that you're doing square root. And then it's going to be a. So I'm left with 4a in 4a. And the square root of 121?
11.
And there's my final answer. Okay. Doesn't matter if there's coefficients on both terms or one term. Okay. So number 10, 12, and then a little challenge for you on number 14. All right, give it a try. All right, so I know we need to all be done, but let's take a look at the answers real quick. So for number 10, we've got x minus 9y times x, sorry, x plus 9y times x minus 9y. Then we have our final set, number 12, 8u minus plus v and 8u minus v. Now the last one's a little trickier, so I'm going to show that one to you now. It looks, so here's that last one. 9n squared plus 5. So when we take the square root of n squared, we go ahead and simply divide. So if I have n squared, or n to the 4th, I take this, when I take the square root, what I'm really going to do is do 4 minus 2. Or 4 divided by 2. And that gives me n squared on both terms. Okay? A little more challenging, but not crazy out of the way. How do we do overall on that one?
Good.
Good? All right.
Good.
All right. Let's take it up one step. So if we take a look at this last set, now we've got a lot more different ones. All right. So let's take a look at a couple more. So we'll do these couple. Okay. We'll do these 3, and then we'll move on to the next section. So staying here. Now, here's my question on this one. What's different about 15 than all the others we've looked at?
5 is a prime number.
5 is prime. So that means the entire number, the entire problem is prime. If this isn't a perfect square, and it's not, I can't use my difference of a square method. So therefore, you can't factor this any other way. You can't find a GCF. No, 5 and 4 have nothing in common but 1, and there's no C's and D's in both terms. So this is considered a prime factor. This number, that is the correct answer. Okay. So now if we take a look at k to the 6th, I'm going to take 6 and divide it by 2 and end up with k cubed and k cubed, and 16 would end up with 4 and negative 4. So I'm going to end up with k cubed plus 4 and k cubed minus 4. And the last one is the same way. On 121, I go, okay, it's really going to be r to the 6th square root, which really means 6 divided by 2. So I'm going to do 6 divided by 2, so I'm left with 11 r to the 3rd plus 1. Use my poor handwriting. And 11 r to the 3rd minus 1.
So the answer to 15 is just prime.
It's just prime.
All right.
You can't factor it. There's nothing left to do. You cannot split it into smaller pieces. That's it.
All right.
All right, and let's take a look at our last, so we've got 2 more pages after this, but this one won't take us that long. This is really bringing in what we did today in the first half of class, in addition to what we're doing now. Neither of these are perfect squares, but we do have to check for the GCF first. If we take a look at both 24 and 54, what number goes into both of those numbers?
6.
Exactly. Well done. So I factor my 6 out, and I'm left with 4a squared minus 9b squared. Now, if I look at this section here, this is the difference of a square. 2 perfect squares in both terms. So I can go one step further and go keep the 6 on the outside and go 2a plus 3b times 2a minus 3b and go one step further. Okay, so in this case, I'm taking what I did in lesson 5 and putting it on top of what I did in lesson 6. But the way to go first is start with the GCF. That's always step 1. Then step 2 is to find factors, whether it is using the difference of a square method we learned earlier, or the one we're going to learn tomorrow when it talks about pretty much its reversed FOIL. So let's take a look at 45 and 20 cubed and cubed. What is the greatest common factor of 45 and 20?
5.
5. Now, my second question, can a variable be factored out at this point as well?
Yes.
So I can, since q is in both terms, I can go ahead and factor out, that's a g, a q, leaving me with 9q squared minus 4. That lets me go ahead and go to the next step of 5q times 3q plus 2 and 3q minus 2. Sorry about my poor handwriting. And now we kind of get to see how those go step by step.
Oh.
I'm recording it now. And so what I'd like you guys to do is try number 26. Okay, start with the GCF first, and then after that, go to the next step. All right, take a look and see how you did. So my GCF in this case is 3x squared. And then when I divide them all by 3x squared, I end up with x squared minus 16. And then I can factor x squared minus 16 into x plus 4 and x minus 4. How did we do? Good? All right.
Yes.
Good. All right, so let's take it and just do a little more practice, and then we'll call it for the day. So what I'd like you guys to try is 33 and 34, okay? Once we get, if you can do those two, you're really solid for these concepts, okay? So you're gonna try 33 and 34, and then we'll come back together in about 3 minutes and see how we did. And then we should be done for the day.
Mr. Molly, I have a question about the last one.
One moment.
4 and plus 5. Does it matter which order, or should it be
I
4
prefer
and
plus 5 first, minus 5 second, but I won't yell at you if you do them backwards. That's not high enough on my list of things to worry about right now.
Okay.
Okay. Ideally, this is the correct answer. Okay. This is the answer that you're going to want to see. All your teachers are going to eventually want to see going, oh, okay, they know that that's the right way to go. That's it. Okay. But in the grand scheme of things, I know I'm picky a lot of times, but I'm not being that picky right now. Okay. All right. So if I take a look at the next one, if I divide, now I look, okay, 4n squared is perfect square, so is 1. When I finish that out, I end up with 3, 2n plus 1, and 2n minus 1. Okay. All right. Questions on 33 and 34? All right, there you go. There's the final answer. Now you can see them now that we've talked them through. All right. So, get back. I'm on camera. You cannot be on the screen. All right. So now let's just jump back and talk about the homework real quick. Here are the homeworks for tonight. They're due on Wednesday. So you've got lesson 7-5 odd, 7.5, the homework 7.5, and I gave you, you already have the paper for 7.5. It was in the last packet I gave you. And then I'm capped on 7.6, which I've already posted online. I'm also going to email you after class is over, is I need you to do 1 through 9 and 16 through 24. That's the first 9 and the last 9. So you get to skip 6 in the middle. Gives you guys a little bit of a break. Again, it's due Wednesday for y'all. Okay.